Yeah, good morning to everyone. In the today's class, we are learning about the relational database design. How you want to design the relational database by using the relational model. If you want to design the database, what are the problems we are facing? Is a very important question for your theory exam. Now, in the today's class, you are learning about relational database design. How you want to design the database with the help of relational model. Now, if you want to design the relational model, first step we should go for the database schema. We should need the schema. Schema means here, if you want to design the schema or if you want to design any table, the table we are calling as a schema. Now under the university database, we are having the around 11 schemas will be there. Now we are considering as per the ER model, when you are designing the ER diagram for the university, already in the second unit you learn, there we are having the entities or we are calling as a database schemas. Here we are having the 11 database schemas. The classroom is a database schema. Under the classroom, it can consist attributes. Now classroom is a schema. Classroom schema, under the classroom's database schema, it can consist 4 attributes will be there. Building attribute, room attribute, number and the capacity. Coming to the department schema, some attributes will be there. Coming to the course schema, some of the attributes will be there. Instructor. Coming to the instructor, we are having instructor ID, instructor name, department name and the salary. 4 attributes will be there for the instructor schema. Coming to the section schema, we are having the course ID, section ID, then semester, year, building room and the number, time slot, ID will be there. Coming to the course ID, this attribute is available under the course schema or the course table. Under the course table, we are having as a course ID. This attribute is available under the section. Section here it is acting as a child. Here it is acting as a primary. Now under the course ID we are having as a unique under the course schema. Then coming to this section, under the section here it is acting as a foreign key. Means what are the values is available under the course ID, those values will be available under the section schema of the course ID. Duplicate values will be there under the foreign key. Now if you want to go for the student, under the student we are considering as a student schema, we are considering as a ID as a primary, then name, department name, total credits will be there. Name, then text is a schema, advisor, time slot and the frequency. These are the schemas will be there if you want to design the relational database schema for your university database server. These are the entities or the database schemas is required. Now coming to the what are the features will be there under the good relational design database will be there. Now, if you want to talk about the features under the relational database, now here we are having the design the alternate larger schema. If you are designing the larger schema, if you are combining the instructor and the department into the instructor table. Now if you are designing the larger schema, just now you saw about the schema. Now we are combining these two schemas, we are making as a larger schema, instructor and the department. Under the instructor we are having, under the instructor schema we are having the ID, name, department name and salaries will be there. This is the instructor. Now coming to the instructor and the department. Under the department we are having the department name will be there, building will be there, budget will be there. Under the instructor also department name will be there. Now when you are combining two schemas, when you are making as a larger schema, when you are making as a larger schema, no connections to relationship set between the instructor and the department table. When you are combining the instructor and the department, two schemas, when you are combining together, when you are making as a larger schema, under the larger schema, no connection relationship between it is existing between the two tables. Now if you want to see the repetitions under the information, if you want to see the repetition, building name it is repeating, building name Taylor and it is repeating n number based on that computer the Taylor is a building is available in the computer science, electrical engineering, then computer science and computer science This it is a painter is a building. Finance, it is available for the history. Then coming to the history, then finance. Means it is repeating. Means at the time of you designing the good database, result is not possible for the repetition of the information. Means when you are retrieving, when you are combining the two tables, we are getting the duplicate values. Those duplicate values is not a good, it is not a data consistency. It is a data inconsistency. When you are combining the schema without repetition, see a second scenario, what are the features will be there means when you are designing the alternate largest schema, the first feature under the designing the schema, after designing, then when you are combining the two more schemas, when you are making as a larger schema, coming to the third feature under the relational database, combined schema without repetition. Means when we are combining the two tables or two schemas, duplicate value should not be there. Consider the combining relationship, section in the class. Section ID, building, room number, and the section we are having the course ID, section ID. Under the section class also we are having the section ID. Under the section class we are having as a section ID. When you are going for the section, we are having as a section ID. Means we are having as a duplicate attributes it is existing. When you are having the duplicate attributes, then only the relationship is existing one table to the another table. Now if you want to go for the no repetition in this case, no repetition in this case means we should go for the designing the smaller schema only. Means if you are getting the duplicate values at the time of your designing the schema, then the alternate solution again we should go for the larger schema. Now instructor and the department table, with the help of the instructor department table, when you are combined together instructor and the department, when we are making as a one table, then we should split into the instructor and the department. Means when you are decomposing the tables, when you are decomposing the table instructor and the department, now we are splitting the two tables. Means when you are splitting the two tables means we are making as a smaller schema. Maybe when you are writing the rules about your relational data model, if there were the schema, under the schema we are having the department name, building, and the budget will be there. Means according for the rule, if you want to design the alternate schema for if the repeated value it is existing, now when you are taking as a schema, under the schema department name and the building and the budget, coming to the department name should be the candidate key. Now here we are considering as a candidate key. Means when you are denoting the functional dependency, department name is depending upon the building, depending upon the budget. Means here the relationship it is existing and the functional dependency will be there. Functional dependency means when the attribute is depending upon the another attribute. Means department name is depending upon the building. Means specific, if you are having as a computer science department, under the computer science department we are having the separate building will be there. For the computer science department separate budget will be there. Here the functional dependency is existing among the attributes. Means department name is the attribute. This department name attribute is depending upon the building. Means here the relationship is existing among the attribute. Here one attribute is depending upon the n number of attribute existing under the table. Department name attribute is depending upon the building. Department name attribute is depending upon the budget attribute. Means here the functional dependency is existing when you are designing the alternate of the smaller schema. Now if you want to talk about the instructor and the department table, when you are combining the table instructor and the department, now with the help of that instructor and department table, when you are splitting the table, at the time of we are splitting, then we should go for the functional dependency. Now department name is not a candidate key. Means based on that constraints, which specific attribute you want to define. Now coming to the here the building and the budget of the department may have to be repeated. means building and the budget department may have to repeat it. This indicates the need of the decomposition insect in the department. Not all decompositions are good. Means when you are decomposing the table, when you are splitting the table, it is not a good. Suppose if you want to decompose the employee table under the employee table, now when you are splitting the employee table into the two tables, employee table 1 and employee table 1. Under the employee table, we are having as a ID, name, street, city and salary. Coming to the employee table 1, we are taking as a ID and name. Coming to the employee table 2, we are taking as a name, street, city and salary. The name attribute is existing under the both the tables, employee 1 and employee 2. Here, the relationship is existing among the ID, employee ID is depending upon the employee name. Coming to the employee table name, again here it is acting as a candidate key. Means department name we should not consider as a candidate key. Means the multiple times the attribute is existing under the table, different table. Here, if you want to see the loss of the information, we cannot reconstruct the original employee relationship. Then we can call as a lossy decomposition. When you are splitting the two tables, employee 1 table and the employee 2 table, when you are combining together, if you want to make as a unique, here the information, where the original information we are losing, then we can call as a lossy decomposition. Now as per the table, now if you are taking as an employee table, under the employee table we are having as an employee ID, name, street, city and salary will be there. This employee table we are splitting in the two tables, employee 1 table and employee 2 table. Now when you are joining the table, what are the existing table, the table we are not getting. This is data redundancy is occurring under the when you are joining the two table. When you are splitting the two tables, after splitting the two tables, when you are joining the two tables, then we should get the same data. What are the existing the first data only, then we can call as this lossless decomposition. Here we are getting as a lossy decomposition. Means what are the existing data is there, the data we are not getting, then we can call as a lossy decomposition. Lossless decomposition means when you are joining these two tables, employee 1 table and employee 2 table, when you are getting as this table, then we can call as a lossless decomposition. Lossy decomposition means when you are joining the table, we are getting the extra information, then we can call as a lossless decomposition. Now if you want to see about the lossy decomposition, if we are lost the information, then we can call as a bad decomposition will be there. Means when you lost the information, then we can call as a, means when you decompose the table, means decomposed means when you are joining the two tables together. Decompose it means the components are the tables when you are combined together. When you are combining together, then at the time of you are combining together two tables, when you lost the information, when you lost the content, then we can call as a lossy decomposition. Lossless decomposition means when the two tables, when you are joining together, at the time you are not lost the information, then we can call as a lossless decomposition. Now if you want to see the lossless decomposition, now the relationship is existing between the A, B, C, D attributes will be there. Now under the relation A and B will be there, and under the R1 relation between A and B attribute is existing. Under the R2 relation B and C it is existing. Now if you want to see under the functional dependencies, what are the functional dependencies existing under the relational database? Now based on the functional dependencies, if you want to talk about that, constraints on the set of the legal relations should be there. Require the values for the certain set of the attributes, determine the uniquely the value from the other set of the attributes. Functional dependency is generalized of the notation of the key. If you want to talk about the functional dependency, just now I said the functional dependency means between the tables or among the attributes, when the one attribute is depending upon the another attribute, means when the relationship is existing, then only we can call as a functional dependency. Functional dependency is a relationship that exists when one attribute is uniquely determined another attribute. Means, for example, if you are taking as a department table, under the department table we are having as a department number, department name and department location will be there. Department number is a attribute. This attribute is existing as a uniquely. It is determining to the another attribute. The department number is depending upon the department name. For example, if you want to talk about the department number for CSE 733, then when the attribute department number is depending upon the department name. If you want to talk 737, department number is 737 is IT. Coming to the name, we are having as a department name is the information technology. Department number is depending upon the department name. Then only we can call as relationship is existing between the two attributes. The relationship is between the attributes of the table depend on each other. What I said, same scenario will be there here. It helps in the preventing the data redundancy. Get to know about the designing the functional dependency and the constraints and the set of the legal relation should be there. Means when the relationship is existing among the two attributes, for that attribute we should define the constraint. Based on that attribute we should assign that constraint. For example, if we are taking as a department number, for department number we are assigning it specifically as a primary key. Primary key means if you are defining the primary key as a constraint for the department number, under the primary key we cannot insert the null values, we cannot insert the duplicate values. These are two conditions, two restrictions will be there under the primary key. Then the department number when you are declaring as a primary key, coming to the department name, the department name may be, if you want to give the uniqueness, then we can go for the unique constraint. Means for department name we are assigning as a unique constraint. Means the department number is depending upon the department name. Department number is depending upon the department name. Now if you want to talk about the A to B, A attribute is department number, B attribute is a department name. It's a functional dependency between the two attributes. The account number, if you want to take, I given the another example. Account number is functionally dependent on the balance of the account table. Now, what are the uses under the functional dependencies? If you want to see about the uses of the functional dependencies under the existing table, if you want to test for the relation to see if the legal under the given the functional dependency, if the relationship R is a legal under the F functional relation. Now if you want to see under the uses under the functional dependence. Now when you are testing the relation to see if the legal under the given the set of the functional dependencies, if the relational R is a legal under the set of F functional dependency, we can say as a R satisfies F. R is a relation is a legal under the set of a set F is a functional dependency. The functional dependency, the relationship is satisfying the functional dependency if the constraints of the set of the legal relational. See the first condition when you what is the main usage under the functional dependencies means when you are testing the relation to see if the legal under the given set of the functional dependencies. If the relation is a R is a relation, is a legal under the set of, is a set F of the functional dependency. Means R satisfies a F, relationship is satisfying the functional dependency. Means relationship is existing among the table, among the attribute. When the relationship is existing means it satisfies the functional dependency. The main usage of the functional dependencies. Now if you want to specify the constraints for the relation, at the time of you are giving the relation between the attributes, we can say that F holds the R, means relation. Functional dependency is holding on the R relation. If the legal relation of R satisfies set of the functional dependencies F, means here if you want to specify the instance of the relational schema may satisfy the functional dependency even if the functional dependency does not hold the legal instance. Instance means the current time, what is existing under the functional, then we can call as a instance. Means the specific instance for the instructor may by chance satisfies the name as the ID. At the runtime, at the current time, maybe the instructor maybe satisfies the name. The name is functional dependency under the ID. Now, if you want to talk about the closest set of the functional dependencies, what are the closest set of the functional dependencies will be there means certain functional dependencies are existing under the logically implemented by the functional dependency we are representing with the help of the capital F. For example, if you want to take A is the relationship is existing B is existing under C, then we can refer that A to C. Means from A to B it is relation is existing, from B to C then it is existing, then we can call as a to C is the relation is continuous relationship, it is existing. All functional dependencies logically implemented by with the help of the F is closer to F. We can denote the closure of the F then with the help of F plus. F is a relation, then we can representing with the help of closure of F plus. F plus is a superset of F. See what it is saying. Now under the functional dependencies we are having as a partial dependency will be the transitive dependency will be the trivial dependency will be the non-trivial dependencies will be there. What is a partial dependency? Partial dependency means if proper subset of the candidate key determine the non-prime attributes we can call as a partial dependency. Non-prime attributes means it is not a primary key attribute. Means when we are giving as a partial dependency means partially it is depending on another one attribute. One attribute is existing, A1 attribute is existing, A2 attribute is a non-prime attribute. Means A1 attribute is functional depending on the A2 means then we can consider as a partial functional dependency. Transitive dependency means we should be the sequence from starting point to the end point. If you are having as a functional dependency among it is existing, then we can call as a transitive dependency. Indirect relationship causes about the functional dependency, then we can call as a transitive, indirect. Then if you are talking about P2Q, Q2R, it is a true, then P2R is a transitive dependency. Indirect relationship is causing we can call as a transitive. Proper subset of the candidate key determining non-prime attributes, then we can call as a partial dependency. Means under that attribute A1 attribute it's partially depending upon the A2 attribute, then we can call as a partial functional dependency. Trivial dependency means if functional dependency f of x, x2 wholes, then y is a subset of x, then we can call as a trivial functional dependency. Means the reverse. The functional dependency of x2 y wholes, where y is a subset of x, then we can call as a trivial functional dependency. Trivial functional dependency always it holds. Non-trivial functionality means is not a subset of y to x, then we can call as a non-trivial functional dependency. Now these are the functional dependency is existing under your transitive dependency, trivial functionality, non-trivial functional dependencies. In the coming class we are learning about the normalization. If you know at the time of you designing the relational database, what are the problems we face? For eliminating purpose, we are going for the normalization. For eliminating the duplicate data, that is the purpose we are going for. Data redundancy purpose, we are going for the normalization. Now, in the today's class, very important. Here, lossy decomposition and the lossless decomposition for the 2 marks, very important. Then coming to at the time of the designing the relational database, what are the functions is required? The first functions is required database schema. At the time of we are selecting the database schema, then first what we are doing? First we are designing the schemas based on the requirement based on your project. First we should design the schema. After designing the schema, then we should go for designing the alternate the largest schema. When you are going for the designing the alternate largest schema, what are the problems we face at the time of combining the 2 tables? then we are getting the repeated, then again we are going for the splitting the data. Again we are going for alternate design for the smaller schema. At the time of your designing for the smaller schema, then we are using the functional dependencies. When the relationship is existing between the two between among the attributes, at the time we are assigning as a functional dependency. Under the functional dependency, maybe it is a partial dependency, or maybe the trivial dependency, or maybe transitive dependency, non-trivial dependency. Based on that dependencies, it is existing. Based on that rules, maybe we are specifying. The next we are going for, at the time of you defining the functional dependency, then when you are joining the two tables, then we are getting the same existing table data, only then we can call as a lossless decomposition. Lossy decomposition means here based on this table, the lossy decomposition means that table is existing. Based on the table, when you are splitting the table together, when you are splitting the two tables, again the two tables when you are joining, then we are getting as a extra information. Then we can call as a lossy decomposition. Maybe if you are not getting the extra information, same data is existing, then we can call as a lossless decomposition. Thank you. In the tomorrow's class, we are learning about normalization scenario.